Okay. The purpose of this is for you to, if you know like what bond type's holding two things together, what that means about that substance's properties in some broad categories. All right. And those broad categories are like what it looks like, its melting point, whether or not it's soluble in water, reacts to acid, and so on. All right. Now, the first bond type is covalent, and covalent, a classic example of covalent is like wax. The wax in a candle is an example of a covalent molecule. And waxes are solid. Another classic example of a covalent molecule is oxygen gas. Oxygen gas is a gas. All right, there are lots of other examples like oils are covalent. So really, covalent tends to be any state. This is at room temperature, um, and even still, even though it can be any three of these things, solid, liquid, or gas, their boiling points and melting points tend to be on the lower end of the spectrum. All right, they tend to be easier to boil, and that's why we have air as boiled already. Um, Wax will melt really easily. All right, these things tend to be insoluble in water. All right, they yeah they don't dissolve when you put water in them. Wax, oil, and water don't mix. All right, they don't tend to conduct electricity. If I take my little battery and I run it right there, it's not going to go. It's not going to jump through the air. That's because covalent molecules are not conductive, and they don't react with acid. All right. Now, a polar covalent, a polar covalent molecule. The classic example is water. Okay, and water is a classic example. Water is a liquid, as are many other polar covalent substances. Some polar covalent substances are solids. These are things like sugar. All right. These tend to have medium boiling points. They tend to be a little bit higher than the covalent. We're kind of going in order here in terms of the boiling points and melting points, and they don't tend to be conductive either as a solution, excuse me, as a solid or in solution. They're not conductive, and however, they are soluble in water. That says soluble there under there. You, water, water can't dissolve itself, but water will dissolve things like sugar and other covalent molecules. However, they don't tend to react with acids. Uh, they will get dissolved by them, but they're not going to react. All right, now ionic, a classic example of ionic is salt. All right, and salts, as many other ionic compounds, tend to be white solids. That's because they've got a really high melting point and boiling point, so they tend to be solids. Um, Much like many others, they're very soluble in water. Salt readily dissolves, as will many other ionic compounds in water. All right, and they're conductive aqueous. That means when they're dissolved, they are conductive, but they're not going to be conductive as a solid. All right. Once they're dissolved in the water, the whole thing together, the solution itself is conductive. However, not when they're a solid. And these things don't tend to react with acids. Now, for a mat, from for a metallic bond type, like something like water bottle, is a classic. That's aluminum. All right. Most things held together by metallic bonds tend to be solids, and they tend to have really high melting points and boiling points. Now, are these things conductive? You can see here this little conductivity test where I've got my bottle there, and the answer there is, yeah, they are conductive. Here the wires are not connected to my water bottle, and here they are, and you can clearly see it's conductive. Now, metals tend to be reactive to acids. All right. Now, one last thing to keep in mind, the reason I put this as a gray is you have to take this with a grain of salt. They're not hard and fast rules. There are some gray areas. Things like water is a covalent molecule. Excuse me, oxygen is a covalent molecule. However, I said that they tend to be insoluble in water. Oxygen is will dissolve under the right conditions, and thank God it does, because otherwise we wouldn't have any fish. All right.